Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to take a look at one more example about the column space. So here we go. We're going to talk about the column space. Column space of the matrix A. Column space of A, and if we recall, we denote that as C of A. It stands for the column space of A. All right, let's take a look at the matrix A as, how about 1, 2, 3, 1, 1, 1. And what we want to do is, for what B does, I don't even think I need a comma in there, for what B does AX equal B have a solution? Have a solution. All right, what we need to do then is let's just work with the problem that we have. So we're given the matrix. We have the matrix here of 1, 2, 3, 1, 1, 1. And let's write the augmented matrix of B. And so that's going to be a B1, B2, and a B3. Remember, those are lowercase. We'll give them a little tail maybe. And then, well, then what do? Then what we do is we row reduce this and see how this works out. So I'm going to work on this one row at a time. Let's try it this way. Row 2 minus 2 times row 1. And I'm going to combine some steps here, so be careful when you're doing this. Row 3 minus 3 row 1. And then let's see where that takes us. So the first row is the same. That's 1, 1, B1. The second row, though, becomes a 2 minus a 2. That's a 0. A 1 minus 2. That's a minus 1. And then we're going to get a B2 minus 2 B1s. Okay? And the third row, then we're going to get 3 minus 3. That's a 0. And then we're going to get a 1 minus 3, that's a minus 2. And then we're going to get a B3 minus 3 B1s. Now, we're not quite done. Let's work on row 3. Let's take row 3, and we're going to subtract 2 row 2s from it. So I'm going to come up here. We'll move over here. So when I do that, now I have the first row is the same. So that's 1, 1, B1. The second row is the same. That's 0, minus 1, B2 minus 2, B1. Now the last row, well, this is going to become a 0. A minus 2 plus 2, that's 0. And then I'm going to get row 3, which is B3 minus 3B1 minus 2 times B2 minus 2B1s. Okay, that's my augmented matrix. Okay. It actually tells us quite a bit. Well, what does it tell us? Notice this last line, this bottom line here, this bottom line, row 3. Row 3 is the row of concern because of this, and I'll try to explain this. Row 3 says that 0 times x, 0x2 has to equal this entire right hand side, B3 minus 3B1. I'm going to start expanding this. We'll clean it up even more. Minus 2B2 plus 2, oh no, plus 4B1s. Now wait a minute. If if this right-hand side is a number like 5, let's just imagine. So imagine. Oops, if I could spell imagine. Imagine the right-hand side is 5. Then what do I have? Well, then now I have the problem of 0 times x2 has to be 5. Well, that's a problem because it doesn't matter what number x2 is. There's no way that 0 times that number is 5. As a matter of fact, this is a false statement. Look at what it really says. 0 times any number is 0. This says that 0 equals 5, which is false. What does that mean? That means that there's no solution if, so that what this means is there's no solution. Oh, let me come back to that in a second. So let's look at the other case. The other case is this. What if, so let's make the right-hand side is 0. Then what do I have? Well, now I have 0x2 equals 0. This is always true. This is always true. Oops. This is true, always true for any x2. So what does that tell us? That tells us this, that in order for this system or this matrix equation to have a solution, then that right-hand side has to be 0. And that's our conclusion, is this system, or the matrix equation, the matrix equation has a solution, when, okay, I'm going to clean that up one more time. I have a B3. And then we have minus 3b plus a 4, or minus 3b1 plus 4b1. So that's going to be plus b1 minus 2b2 equals 0. That's the only time that we have a solution to this problem. I'm going to end here. Thanks for watching.